AI app builders sometimes can also be called AI, which sometimes can also be called AI agents, are not just building mocked up or prototypes. They are building real ones. There have been several instances whereby people have published working products using AI app builders like Vigo or Vessel. As you can see, also build a temporary product with it. This product is published, but it is not in the final stage. Other product that I'm also testing, other AI building agents I'm testing out is Lovable, and a third one which is also, and then a third one I'm also trying out is Replit. As you can see, the working interface over here. In this video, I will show you an app I built using the Vessel. Compare the functionality of this app to a traditional website that does the same thing. In fact, this app was built using the knowledge that was adopted from the traditional method and was just vibe coded into this tool for the tool to generate this app. And in fact, this app is doing a wonderful prediction. So first of all, let me introduce you to the Replit PTS1. So Replit PTS1 is a protein prediction tool that was built by the Lovable Lab. So what this tool is that you copy a protein sequence, particularly plant protein sequence, you paste the amino acid sequence over here, and the tool is able to predict based on the last 10 amino acid sequence of the protein. The tool is able to predict whether a protein is targeted to an organelle called peroxisome. Peroxisome, in a nutshell, it's one of the numerous organelles in the cell. It is bounded by a single membrane, and it does not encode its own protein. Then, after protein is encoded, the protein is driven into the matrix of peroxisome by peroxisome targeting signal. One of the targeting signal, or the strongest, is the PTS1 peroxisome targeting signal. And you also have the PTS2 targeting signal. Other proteins are also targeted to this organelle by piggyback impulse. In this video, I will show you how this tool functions in a nutshell, and I will try to give a detailed tutorial on that later on. So basically, you paste your protein sequence here in this tool, and then you hit on predict. The tool is able to predict whether this protein is targeted to peroxisome, and it gives some other, and it gives some, not only does it predict, it gives you a raw prediction, but then it also gives you score. And here on the screen, you can see that here, so it shows the last 4 amino acids precisely. To be specific, the last 3 amino acid sequence here is SKL, which is a strong peroxisome targeting signal. You can see on the screen that the total score is given here, a threshold, and here it says the protein is predicted to contain a PTS1 domain for peroxisome targeting. And the tripeptide, which is the SKL, which has also been experimentally verified. Now let's paste the similar sequence in my peroxisome AI, which is the tool that I find coded. So first of all, let me show you the interface of the tool. The tool I web coded has a very user-friendly interface. It is supposed to be more robust than the traditional one, but it is still in its infancy. Here we have the home page where it gives you an overview of all the different sections of the tool, and then you also have a dashboard that tells you the total predictions you can do, the average confidence, and the AVG processing time. It also gives you a pie chart of the number of proteins, The total number of proteins that have PTS1 targeting signal, PTS2, proteins that are piggybacked, and proteins that are non-peroxisomal. Now, if you go to the prediction section and then we paste our amino acid sequence, you hit on predict. You can see that here the tool also predict the positions of the last 14 amino acid, as you can see over here with their score. And then, similarly to the traditional tool, the vibe-coded tool predicted that the protein is strongly targeted to the peroxisome with a very high confidence, and it also generated the last 14 amino acids which are driving the protein to peroxisome. Let us now test another amino acid sequence with the classical tool. So here is another amino acid sequence of a viral protein, and we do not expect this to be peroxisomal. So we hit predict, and the protein is not predicted, or it's not experimentally verified to be peroxisomal. And the prediction tool also predicted that the protein does not contain a PTS1. When we paste again this protein sequence in the vibe-coded tool, we hit on predict, the tool predicted that the protein is targeted to the cytosol. So all in all, vibe-coding tools are not just building prototypes or mocked up. They are building real work that people can publish. I thereby encourage scientists, wet lab scientists, bioinformaticians, and all in sundry. And as much as we are doing our work with already existing tools, now the advent of vibe coding can help us generate tools that can be used to test our work. It can also be used to predictions of things that do not yet have tools for their prediction. Therefore, it is encouraged that we do not wait too long to test vibe coding tool. We do not wait until we feel like now the tools are more robust to do their work. And this way back in 2024, 2025, most of these vibe coding tools were already doing their work. And if you should wait too long, by then, those who started using the tool in the beginning would have an advantage than those who start later. So my encouragement is that start using AI building app tools or AI agents now. Subscribe to Ntiri Lab. Let's keep the fire burning together.